Over the past 10 years, the assembly and development of the International Space Station has been a symbol of America's global leadership in space and a crucial investment in technology, new industries, and jobs for current and future generations. The International Space Station is now on the verge of becoming the world-class research laboratory that it was envisioned to be, providing scientists on Earth with a unique environment in which to study and better understand our planet, our environment, and ourselves. Since the launch of the first component in 1998, the International Space Station has evolved from a construction site in space to an international research facility hosting investigations into materials, human and biological sciences, as well as our changing planet. And now, as the station nears completion, the stage is set for expanding space-based science and research with the potential of unlocking secrets to improving life on Earth.
When we designed the space station, we developed a set of laboratories that were really aimed at addressing a variety of scientific disciplines. The needs for human research, for physiological research, the needs for life sciences research, for physical sciences research, materials analysis, and a variety of technology tests. And we built a multi-purpose capability that can address all of those needs.
We are building a science platform in a zero-gravity environment that will allow us to learn things that we couldn't have ever learned in the past.
In a microgravity environment on orbit, things change. Physical properties change, chemical properties can change, and our goal is to find out as much as we can about living in that environment.
We're figuring out how humans can live and work together on an international basis in outer space, and to figure out what that means to the human body, and all of that knowledge that we'll learn in terms of physical impacts and physical benefits to the human anatomy, I think will ultimately translate back to the ground in terms of physical therapy and training and ways to help folks on the ground.
For exploration, what's important about the space station is it gives you an opportunity to test the technologies that you need, to be sure that they'll work for a long enough period of time, that they'll function during a microgravity transit between Earth and some other body, and also to test the ways that we keep human beings healthy during those human missions of exploration.
You know, we have people that are studying crystal growth for better electronic devices. We have people studying smoke detection so that we might make better smoke detectors for spacecraft and homes. We have people that are studying nutrition for astronauts, which may benefit folks in the way that we feed and nourish people on the ground.
The unique physical properties and effects of microgravity in low Earth orbit provides a unique perspective on our planet, our technologies, and ourselves. This creates the opportunity to virtually rediscover our world through fundamental research.
We all evolved in a 1G environment, and the human body and all the cells within the body are used to a certain gravity vector being present, and they're used to functioning with that known vector being present. When you take gravity away, you're taking away a physical factor that the body and the cells in the body have adapted to. And when you take that away, amazing things happen. Exposure to microgravity becomes a tool to be able to uncover things that you cannot do here on Earth. When you look at cancer cells, a lot of people typically culture them in petri dishes, and that's what people are used to, is seeing a flat array of cells. That's not the way cells grow. They grow in 3 dimensions.
Right now we have national laboratory research going on that is aimed at identifying a potential vaccine to treat salmonella, which is a source of foodborne illness. And that vaccine development came from a fundamental research objective where scientists identified that there was a change in virulence in the salmonella in space. And then scientists have taken that and are now purposefully doing experiments to see if they can use that knowledge to create a vaccine that might be beneficial on Earth.
We're literally using the environment of space to be able to create products for Earth. In this case, a salmonella vaccine. If we're able to find a vaccine to alleviate these problems, this would be a huge advance to everyone here on Earth. As a scientist, I can tell you that there's been good proof of concept for the tissue engineering type work, for growing cells in 3-dimensional configurations, for drug testing, for understanding how mediators work in cells, for microbial research to understand why bacteria, why microbes in general make people sick, to uncover ways to better attack them, to better treat them, to make vaccines. I think it's endless, the possibilities.
Learning to purify and recycle precious commodities like air and water is essential for long-term human space exploration. New technologies for recycling human waste into pure drinking water and breathable air are being demonstrated and refined right now on board the International Space Station. These technologies have the potential to restore health to drought and pollution-stricken communities on Earth. Techniques derived from this research are already enabling world humanitarian efforts to restore drinkable water to Kurdish villages in Iraq, remote communities in Mexico, and to disaster recovery efforts in Malaysia and Pakistan. The ability of astronauts on the ISS to detect, observe, and capture unique imagery of the effects of man and nature on our planet adds value to remote sensing and imaging done by satellites or human-tended platforms.
First of all, the astronauts can notice things. It adds the power of the mind and the human eye to see, oh, look at that, and take a picture. Secondly, the astronauts can take oblique views which reveal the three-dimensionality rather than the straight-down views, and that three-dimensionality helps us understand and interpret things like mountains and valleys and river flows and so on. It's very important for us to understand how our planet changes, how the human behavior impacts on climate change. It's not just a question of the temperature warming, it actually has large ramifications for the global ecosystem.
Eager for the opportunity to explore beyond their home planet is a younger generation, whose future will largely be defined by the vision and ingenuity of today's leaders. Our nation's commitment to invest in exploration and research is of vital importance to these young Americans.
Kids in school, elementary, middle, high school, and beyond, can use these perspectives to understand Earth in ways we never could even imagine before the space age. It has truly revolutionized Earth and space science education.
With bipartisan support and the full backing of Congress, the International Space Station is poised to reach the nation's goal of exploration and discovery, stimulating industries and jobs, securing our position of global leadership, and enhancing the quality of life right here on Earth.
The United States is in a unique position to lead the world in microgravity research, and the amount of data that we get back and what we learn about ourselves and our environment, I think the return on investment for the taxpayer's dollar is very, very large.
And like anyone, when you invest in your home and when you invest in your car, you want to see those things utilized to their fullest. And I think that it's incumbent upon us to continue to use the station, to fly crews to the station, to take scientists to the station, putting those minds in a place where they can design new experiments or enhance or change the experiments that we're doing currently. I think we have a great test bed for a lot of new knowledge.